In this video, we are actually going to learn about how to use cosine, which is another trigonometric function. And we've been using sine, and I showed you the law of sines, but you can also solve for missing links of triangles using cosine. And it's going to look a little different because cosine represents something different than sine. Notice that in the past, we had a triangle like this, and I told you that sine represented the opposite side over the hypotenuse. And so we were always looking at an angle for using sine, and then finding the angle that was opposite it. For instance, angle A's opposite side of the triangle is A. And the opposite from angle B is side B of the triangle. And the opposite of side C is going to be side C of the triangle, the hypotenuse, right? So that was the law of sines. So cosine is a little different. So I'm going to go ahead and I'm going to write right here, cosine theta. And when I say theta, this just represents some angle. And cosine theta, regardless of which angle it is, whether it was B or A, is going to be the adjacent side over the hypotenuse. So it's different than sine, because instead of the opposite side, it is the adjacent side. Now, some of you might be wondering, by this point, you probably understand what the word adjacent means, but in case you're confused by it and you go, Mr. H, I don't know what you mean by adjacent. Well, let me give you an example. Let's say that I am looking at angle A, right? So I'm going to start out kind of just like we had started out with the sine one. So, right, if this was sine, we would have used A. We would have said that angle A has a relationship with A, and we could set that up as a proportion. But when it comes to cosine, we use the adjacent side instead of the opposite. Well, the side that's adjacent to angle A is side B. So I'm going to highlight B real quick. Notice it's adjacent because it is beside angle A and it touches it. Now, I did say it's adjacent, but I also said it's the adjacent side over the hypotenuse. Remember that the hypotenuse, I'm going to represent that with my orange highlighter, is always this side of the triangle. It's the longest side of the triangle, represented by the letter C. And one way you always know it's the hypotenuse is you can always draw an arrow from the right angle and it points to the hypotenuse, which is C. So we're going to use cosine to solve this problem instead of sine. Now, of course, you could solve it with sine, but we're going to use cosine so you can see a little bit different method. And so what I'm going to do is I'm coming over here. I see that I have an angle of 37 degrees. And it's asking me to find a value for A, one of the legs of the triangle, and a value for B, the other leg of the triangle. So I'm going to start with this first one here. For instance, I'm going to go ahead and highlight my angle. This angle is 37. And so if I want to find the adjacent side of the angle, it would be side B. So side B is adjacent to 37 degrees. So when I write this out, I'm going to write simply cosine 37, because it's 37 degrees, is equal to B over, in other words, my adjacent side, right? The adjacent side is in the numerator, the hypotenuse. And in this case, the hypotenuse is across from the right angle, and it's 22. So hopefully you can see how I set this up. So cosine 37, this angle of 37, is equal to the adjacent side of that angle, which is side B. So that's why I put a variable B there. We don't know what that value is, over the hypotenuse. And our hypotenuse is 22, so that we know what that value is. I'm going to highlight the hypotenuse orange real quick. So now all I got to do is just solve this. Now this may look confusing to you because I set up this ratio here, but remember what we can do when we solve for a variable. For instance, we're solving for B, we just need to isolate B and get it by itself. Now right now, because of the way that it's set up, because we have our adjacent value over our hypotenuse value, we have to go ahead and use inverse operations. And B over 22 really means that B is being divided by 22. So you got to ask yourself, well, what is the inverse operation of division? Or another way to say it is, what is the opposite operation? And the opposite of dividing by 22 would be multiplying this by 22. Now whatever I do to the right side of the equation, because this is an equation, I have to do it to the left side. So I'm also going to multiply cosine 37 by 22. Now remember this rule that anytime you multiply a fraction by its denominator, the denominator cancels. In other words, these two values cancel out over here. And so all we're left with is just b is equal to. And now on the left side, right, because we also had to multiply that 22 over here, we can simply rewrite this as 22 cosine 37. And anytime you have a number sitting beside cosine, sine, or tangent, it just means it's being multiplied. So why notice up here I put the dot to show you what was happening. I didn't put the dot here because it's not necessary. I know as a mathematician this is being multiplied. All that's left for me to do is put this in a calculator and see what it's equal to. So I'm going to rewrite it with b on the left. I'm going to put b equals, and we're going to put this into the calculator real quick. So I'm going to get my calculator and I'm going to type in 22 cosine 37 degrees, enter, and it gives me 17.569. I'm going to write that value down, 17.569. And since most of your teachers have been asking y'all to round to the hundredths place, that's what I'm going to round to. So the hundredths place is the second number after the decimal, and then I'm going to look at this thousandths place, and it tells me whether to raise the score or let it rest. Let it rest means to leave it the same. And remember, 4 or less, you let it rest. Of 5 or more, you raise the score. And 9 is definitely above 5, right? It is in that category of 5 or more. So we need to change this 6 to a 7. And my final answer is simply going to be b is equal to 17.57. And that's because we raised this 6 to a 7 because the 9 after it told us to change it. Now I'm going to go ahead and box this answer. We know what b is. So we have solved one of the values for the triangle. This side of the triangle is 17.57 units long. Now we do need to solve the other side. And because I'm trying to teach you a lesson on cosine, I'm going to use cosine to solve for a as well. Now we do run into a problem here. And the problem is, if I go over here to this angle, what I would normally call angle B, right, in our diagram, angle B, I notice that there is no value here. So we do need to know what this angle is before we can actually use cosine. So what I'm going to do is I'm going to use the angle sum theorem to figure that out. For instance, I know that every triangle, if I add up all three angles, equals 180 degrees. And I know that this angle right here has a right angle symbol, so it's 90 degrees. I know this angle is 37 degrees. So I'm going to subtract 90 and 37 from 180, and that'll tell me what this angle is here. In other words, I'm just going to write this out. 180 minus 90 minus 37. And we'll see what that gives us. And if we put that in our calculator, it's 180 minus 90 minus 37. And that leaves me with 53 degrees. So I'm going to write right here, 53 degrees. Now with that being said, since we know this angle now, and we know that the adjacent side of this angle is A, I'm going to go ahead and write over here on the left how we would solve it. So we will go ahead and say cosine 53 is equal to A, because A is the side that's adjacent to that angle that touches it, over the hypotenuse value, which the hypotenuse is 22. So we're setting it up just like the other problem. So now that we got this set up and we have cosine of 53 is equal to A over 22, which is our adjacent side of angle 53, over 22, the hypotenuse, we got to go ahead and use inverse operations to finish solving it. So what I'm going to do is A is being divided by 22, so I'm going to do the opposite, or inverse operation, which will be to multiply by 22. I've also got to multiply the left side of the equation by 22 to keep it balanced. And so when I rewrite this, Notice that anytime you multiply a fraction by your denominator, it cancels the denominator. So on the right side of the equation, I have a is equal to, and on the left we just have 22 cosine 53. And now I'm going to go ahead and put it in my calculator. So if I put this in my calculator, I'm going to put 22 cosine 53, hit enter, and it gives me 13.239. So I'm going to write that down. So A is equal to 13.239. And if we want to go ahead and we want to round this to the hundredths place, that 9 tells me that I have to change the 3 to a 4. So my final answer is A is equal to 13.24. And now you know how to use cosine to solve for missing side of a triangle.